Okay, I just started with recording, so good afternoon once again, everybody, and I hand over to Atina. So, Atina, the floor is yours.
Yeah, thank you very much, Vlado. Yeah, good afternoon, everyone. Who would have imagined that we meet for the Inspire conference in this virtual room? But it's great that we have the opportunity, and it's fantastic to see so many people joining us. The session is about OGC API features, a game changer, and has been also questioned about OGC API and OGC API features. So we will have presentations from my colleague Kobe Hobona, who will give an introduction to the topic, timeline, why are we doing what we're doing, and then we have Thorsten Reitz from Retransform asking questions like alternative encodings, alternative Jari Reini from the National Land Survey of Finland will talk, as well as Nuno Oliveira from GeoSolutions. And and then we have a joint presentation, and I guess Paul will present on early OGC API implementations. So, but let's start. We have limited time. So, Gobe, I hand over to you. The floor with the technology, so he will change the pages if you indicate.
Okay.
Good.
All right. Thanks, Atina. Right. Okay. Good day, everyone. So my name is Kobe Hobana, as Atina mentioned. I work for the Open Geospatial Consortium, also known as the OGC, and I will be giving you an overview of OGC APIs over the next few minutes. Next slide, please. Okay, thank you. So over recent years, OGC has found that web APIs have grown in terms of popularity, and this popularity has come about because APIs, some web APIs, have proven themselves to be an effective method for rapid software development and integration. Now, this growth in popularity has also resulted in a proliferation of APIs. The APIs have come in a variety of forms, and what we have found is that to an extent, they have, the proliferation of APIs has degraded interoperability to an extent. So, as a standard development organization, we have embarked on an effort to develop open standards that help to improve interoperability within the area of web APIs, specifically those web APIs that deal with geospatial information. Now, what we're saying to organizations is that they have to start preparing for that transition. Now, you have probably seen statistics published in a variety of different places, but one key thing to remember is that OGC web services have been deployed across the globe. There are hundreds of thousands of OGC web service implementations offering millions of data sets. Now, so with the existing baseline, we're now effectively transitioning, moving forward, and taking a number of the technologies that are out there and developing web API standards that implement those technologies. So next slide, please. Next slide, please. Sorry. Okay, yeah. Now, as we're doing that, we're also going to be maintaining the existing OGC web service standards. So as we're developing this new set of OGC standards, specifically the OGC API standards, we're also going to be maintaining the existing set. However, we'll be placing more effort into OGC API standards, and therefore we're advising organizations to start planning for that transition. Next slide, please. Now, the approach that we're taking to develop these OGC API standards is effectively we're leveraging the guidelines and the best practices that have emerged from work done by both OGC as well as by our alliance partners such as the W3C or the World Wide Web Consortium. So the spatial data on the web best practices is an example of it provides us examples of those guidelines that were defined by OGC and W3C. But another key aspect of the OGC API standards development activities that were putting the developer as a key consideration in what we're doing. We're trying to ensure that the standards become as developer friendly as possible. And we're using the concept of building blocks. So with the whole building block approach is that we want the OGC API standards to enable implementations to be able to be easily integrated such that you can develop a solution by bringing together a number of different OGC API standards. And we're doing all the work out in the open. The standards working groups are using GitHub, public repositories on GitHub, and engaging widely with the community. Next slide, please. Now, just to give you a list of the standards that are out there and under development, we've got OGC API Common, OGC API Features, OGC API Coverages, Records, Processes, Tiles, as well as Environmental Data Retrieval API. And we recently kicked off activities through new standards working groups that will focus on styles and routing. Of course, today's discussion will focus on OGC API features, but it's important that you keep in mind as well how the OGC API features standard basically fits within a broader picture of OGC API standards. Okay, next slide, please. And all of these standards are being developed using contemporary technologies, including, for instance, OpenAPI. So the standards are being defined using OpenAPI in order to make it possible for developers to easily pick up the standard and implement to it. We want to make the standards as developer friendly as possible, and that is why we are using OpenAPI as a key component of these standards. Next slide, please. Okay, thank you. So one of the previous slides, I showed you the list of standards, and what this slide shows you is the roadmap for each of those standards, as well as a few other related ones. You can see that in terms of 2020, 2020, we're pushing ahead with an enormous effort to to get parts of OGC API features published, but also a number of other related standards, for instance, the coverages, tiles, maps, and other APIs. So given that today we're focusing on OGC API features, please just press once, click once. Okay, so given that we're focusing on OGC API features, I'll also point out that not only have we published the standard, so OGC API features part 1, which is the core part, not only have we done that, but we've also successfully developed and published the compliance test suite for that particular standard. So you'll find on the OGC website a link to the compliance test for OGC API, the compliance testing engine, which offers, as one of the tests available, it offers OGC API features part 1. And implementations of that standard can be tested, and those implementations that pass can then apply for certification as being OGC compliant. In addition to the work that we're doing with OGC API features, we are also currently running an invitation for public comment for OGC API Common and also OGC API Features Part 2, which will focus on coordinate reference systems. Okay, thank you. Next slide, please. As I mentioned, there are a number of parts to each one of these standards, and the two other parts for OGC API features include Part 3, which covers the Common Query Language, CQL. Those of you that have experience with catalog services for the web or CSW, you'll remember CQL, the Common Query Language, was a component within CSW. So what we're doing now is pulling that capability, that model out, and making it possible to apply it to a number of standards. And OGC API Features Part 3 will describe how it should be applied there as well. Next slide, please. Now, to help us develop these standards, we're running a number of sprints, hackathons, pilots, testbeds, and other activities. What you can see on the slide is a list of previous ones, but also other initiatives that we're currently running. Testbed 16 is ongoing, and it has a number of OGC API related activities, including one that applies OGC APIs to SWIM. So that's the aviation system-wide approach, information management approach. But there's also an activity in testbed 16 that's looking at discrete global grid systems and how the OGC API approach can be applied there. I'll point out a special one with regard to OGC API features. The 3D data container and tiles pilot is looking at how you can use an implementation of OGC API features as well as other standards, how you can use them to deliver 3D tiles and other 3D data content. That's an activity that I think a number of people on this call today will find of interest. Next slide, please. So in summary, OGC API standards will be a key aspect of how we achieve cross-community interoperability in the future. And this will become even more important as the number and the variety of web APIs continues to grow. OGC Web Service standards, which are broadly and globally implemented, will continue to be maintained, but most of the effort will go into developing the OGC API standards as we move forward. And organizations, both end users and data publishers and other organizations involved in geospatial data, are being advised to start planning for that transition, so transitioning operational systems towards OGC APIs. Thank you for your time.
Okay, excellent. Thank you very much, Gobe. And some of you might have questions. Please write them down because we will have a question and answer session at the end of this session we are right now running. And I would like to ask Thorsten Reit from vTransform for the next presentation. And Thorsten is looking into alternative encodings, alternative APIs, alternative models. And Thorsten, the floor is yours.
Thank you very much. I assume you can see my screen?
Yes.
Great. Yeah. Hello, everybody. Nice to welcome you to this afternoon session. Yes, you might have noticed I've changed the order a slight bit of models, encodings, and APIs because I think the basis is like the model. Then we encode the data in the model, and then we deliver it through some API. So I decided to follow that. First of all, thank you very much to Gobe and also to the speakers in the previous session. So they've provided a nice introduction already to many of the concepts and so on. So my focus will actually be on how models, encodings, and APIs are kind of interrelated and have to work well together to really deliver on some use cases. Since I used the word alternative 3 times in my title already, I think it's important to quickly clarify that what it means, especially in the Inspire context. And yeah, basically the things that we work day in, day out with are the Inspire data specifications and the network specifications. So those we can kind of consider to be the default encoding and service options. There's already some variance in that, for example, in how we can implement a download service. But generally speaking, those are like the the core thing of what Inspire today gives us as technical guidance. And then in addition to that, there's two things. On the one hand, we can have an additional encoding, which is pretty much something that we do in addition, that hence the name, to the default option. And the nice thing about having additional options is that they don't have to satisfy all implementing rule requirements. And for example, the data owner does not need to prove any compliance because that's basically handled by doing the default variant. That also means there's no central tooling and the like required. However, an alternative really means that we switch. It means we don't have to use the default, but rather we can also use the alternative. But that means again that the alternative encoding API, whatever, has to satisfy all legal requirements and that compliance needs to be shown. At this point, we don't yet have much tooling, but that is likely going to change over the next 1 to 2 years, I think. So with that clarification out of the way, as mentioned, I would actually like to start from the models. And something we did a few years ago was that we started to actually measure how complex different models that we work with are. Just to give you a perspective, so here on the left-hand side, we have the one. One is basically a single table, no complex attributes, etc. Basically the most simple data model there is. Whereas here, the 10, that's tend to be models that are huge, that have huge cyclic dependencies, that have all kinds of associations and so on. And this is kind of a simplified classification. But what we can see is that on the one hand, we have a large number of data models that fall in the very easy category, and then kind of a normal distribution. And often those that fall into this very easy category are actually extracts from more complex models like shapefile exports or CSV exports from a database. What you can also see is that the Inspire models are basically in the same area as the other models. So those are the blue ones at the bottom. So from speaking from that, there's the question of whether we deal with an, let's say, inordinate amount of complexity in these models, or whether they are simply describing some things that have some complexity, basically simply as part of the real world features we are describing. And yeah, in our view, there are actually quite a few points that you could not really simply reduce the complexity much more. But of course, there are also ones that we could deal with. And usually one of the most common ways that we deal with is first and foremost to identify areas of over and under specification. So what places are things where there's a lot of like types and properties that are not really used? That would be over specification. And areas of under specification are also typically identified because, for example, when you map existing data into them, you have a lot of information loss, and you can't really capture that in the target model. It's also possible to identify structural overhead. Like, for example, if you have a single property, but it's nested 7 levels down, then that's a lot of structural overhead. That's something we can identify easily. And we can, of course, also use normalization and denormalization if we have different goals in terms of how we want to deal with complexity. And although the flattening and so on that we hear about is a form of denormalization typically. Yeah, and one that's particularly common to deal with model complexity, and one that I've been working with for like 25 years, or and most of you too, is actually to use views. I mean, pretty much any system that you've been using in the last years probably employs the concept of views. So you have database views, you have model view controllers and applications and so on. The purpose of views is, of course, to make sure that both the user or the client doesn't have to deal with the whole complexity of the model that you're using in the background for any given part of the application or process. Yeah, and in the GIS community, we even have a fixed term for that, in my view, and that's kind of the layers. Yeah? So typically what we have is that we have cartographic layers that are built on views on the data model itself. And for these views, we do things like we filter, we join, and we denormalize. And that usually is a really important aspect that helps us deal with, let's say, complex models. A good example of how this can be handled is in the geo package encoding, where you actually have views as part of the delivery package. So you can have the full model in the geo package as a fully fledged database, plus some views that are really helpful, for example, for a GIS user. Yeah, so however, I mentioned that there are also things where we can definitely reduce Inspire model complexity. And here I'm going back to a report we did for the BKG, for GDIDE in Germany a few years back, which was basically about finding or giving a set of recommendations how to reduce Inspire model complexity. We've seen this in the presentation by Spatineo before. So they've also shown that there's first a set of model transformation rules applied, i.e. simplifying the model itself before we actually apply the encoding. And that's really important. If you don't do both, then just switching to another encoding is going to give you very, very little benefit in most use cases. So some of the specific recommendations we had here, for example, was that we substitute types with a large structural overhead, like the aforementioned. If you add a single property 7 levels down, then there's too much overhead quite naturally. But also to reduce usage of choices and substitutions. And that also helps interoperability, because when there are fewer options, that basically means that all the data sets that are being put up on the infrastructure are going to be more similar. Another thing we proposed was basically to extract dataset-wide constants. Like, for example, I haven't seen a single dataset yet where null reason wasn't constant across a dataset. So it could easily be factored out. Yeah, and then there's sometimes inconsistent obligations. Like, for example, on a nullable property, you still have to encode UOM, and those things should also be done away with. And that would, on average, help to move the Inspire model complexity down by 1 to 2 classes. However, the rest is kind of necessary complexity. Yeah, and now that we've kind of had the model view out of the perspective, the next question is, how do we actually encode it? And the GeoJSON alternative encoding project was mentioned. Basically, what was clear, at least to me from the beginning, is that GeoJSON is not like a silver bullet or anything, but it's well suited for some use cases, in particular for consumption in web and mobile applications. You would typically use it for a small payload, so definitely less than 10 megabyte. You don't want to request a 10 gigabyte file in GeoJSON. That doesn't make sense in most web and mobile application cases. There's also some limitations on the type of geometries that you can use. So for example, you don't have curves and so on. And you also have to deal with limited precision geometries, among other things, due to the requirement to use basically just one specific spatial reference system. On the other hand, that means that GeoJSON is not the one-hit wonder that solves every problem. Like, for example, for a performance critical or mobile application, you would not use it. And why is something I'll show later. So for that, you typically use proto buffers, flat buffers, UTF-encoded array buffers, and the like. So those are much, much more effective in many dimensions. You would also not use it for large payloads because it's actually a rather inefficient encoding compared to some other options. I mentioned the geometries and precision issue, and there's also far less tools on GeoJSON for quality and validation. So if you compare that to the GML stack, where we do have the schema validation, we have things like Schematron, we have the ETF framework, etc. So there's a whole ecosystem ranging from very general to very specific that allows us to perform in-depth quality assurance. And on GeoJSON, the tools are not comparable at this point. So in my view, the optimal use case here is clearly web application accessing individual data sets. GeoPackage is also an alternative encoding that we've been working on. Well, actually, I have to say this work is being done by Unizar in Spain with only a little support from us. And GeoPackage is really well suited for consumption in desktop GIS, so as a replacement for shapefiles or file geodatabases even. You can easily deliver whole data sets. They can be large. Pretty much all types of geometries are supported in any projection system, and you have the views as mentioned. But it's not really that well suited, for example, as a response format to a web client requesting a single feature or a small set of feature, because there's quite a bit of overhead in that. So in my view here, clearly the optimal use case is to deliver an entire data set with multiple tables to GIS users. And then we have GML, the default encoding, which also has its cases where it's good for. Like, for example, it's actually well suited to maintain all that kind of information richness that we have, all types of geometries, including curves and so on, high precision. We can also encode without any information loss, really complex models in the backend and so on. On the other hand, it's really not well suited for direct usage in desktop or web GIS. I mean, that's something we've seen in the past 10 years to infinity and beyond, I guess. So in my view, the optimal use case for GML is actually that it's the format for systems data exchange. So I consider it very much to be a kind of middleware component. And on that topic of which encoding you can use for what, there's actually been, as part of that work we did a few years back, there was also this Can I Use study where we looked into how different tools can actually work with different encodings. And I just want to give a shout out that we should still try to continue keeping that up to date as things evolve and also as we add new encodings. I promised before that I would also say something related to performance. And I collected these numbers. The size ones are numbers we made ourselves on a test case. The right-hand numbers come from Björn Hartel, who did work on flat GeoBuff. And I just want to point out a few things. So that is really a clear indication of what's used where and how. So the first thing I want to say is that as soon as you zip things, it's basically just the information content. Yeah, they are not that different. Yeah, you zip a GeoJSON and it's almost the same size as shapefile, GeoPackage, and whatever. Yeah, so as soon as you factor in the actual, let's say encoding, including zipping or other formats of compression, the size is not really a differentiator anymore. However, where we do have differences is really in reading. Yeah, in writing, not so much. That's pretty much linear to the data volume, to the uncompressed data volume. But where we have really big differences is in reading the data. We can see that GML is actually 8 times slower than GeoPackage and shapefile. And GeoJSON is 15 times slower than GeoPackage and GeoJSON. Yeah. So we really have to see that this is obviously something, if we have performance critical applications needing to write that, then those two options are not optimal. Needing to read that, sorry. And if we directly want to read it with a filter, it gets even worse, which is kind of to be expected because shapefile and GeoPackage have indexes, so it doesn't actually need to read a lot of data. And flat GeoBuff has a random access structure, so you can immediately access any object, so it's really fast for that. As a side note, flat GeoBuff would be the only format I would use to actually do a visualization. Do a visualization application on top directly without loading in some intermediate structure. Yeah, the final part of the story is the role of the API. And here I've just compared the vector download services. So on the one hand, we have the WFS, the classical one, the feature API, and also the Inspire option of a predefined download service. And for WFS, we still have to say it really has a very powerful query language, yeah, but it also has a lot of downsides, which I think are pretty clear and everybody understands them now. One thing that I'd like to point out is that, for example, things like the implementation of pagination is really inconsistent. So that's kind of annoying. And so it's really good to see that the feature API has an implementation of that that's far more in line with the let's say with the rest of how the web deals with these things. I think the general description of that was already provided. So it's relatively easy to integrate in modern apps and services. It's easy to implement. Yeah, feature API implementation is much quicker to do than a WFS implementation. However, there's also still some limits. Yeah, and those are basically that the core class is not nearly as powerful as WFS. And I think to kind of get to the point where it's really a full substitute, we will need the CRS extension, a temporal extension, maybe something like either the CQL, the Common Query Language, and or GraphQL extension. I must say that I would prefer the GraphQL one. So predefined download service, I think that's still the option if you want to download everything. Main problem from my perspective is that Atom Feed is really not well supported anymore. So in my way, that's kind of clearly deprecated, the way that we're currently doing that. Yeah, and the way that I see this whole thing is that basically I personally treat the Inspire defaults as kind of middleware. So I create the mapping to harmonized GML data and can then automatically derive anything I need, GeoJSON, GeoPackage, whatever you like. And I treat the services at this point still similar. So I create the setting for a harmonized service once and then derive other services from that. But I also have to say that I think that the WFS can indeed be replaced relatively quickly with the feature API or others. Yeah, that's more or less the key on the comparison of these. One thing that I want to specifically mention is that to implement this approach where you just create the harmonization mapping once and get all the encodings, this is that in Hail Studio. We do have the key encoders that I mentioned, What's still missing is to integrate all the model transformation rules that were mentioned both by Sampo and by others before. So that's something we started working on. And if you want to support that or have your input to that, then feel free to join the Health Studio community milestone planning meetings. The next one's on the 2nd of July. And just reach out to me if you want to be part of that. Yeah, so a few takeaways. So I think it's clearly the case that you have to select your encoding per use case. There is no silver bullet. Alternative APIs, my simple answer is yes. So I think we can and should transition to that in a few years, maybe 1 or 2. And regarding my main approach for dealing with model complexity, in addition to basically evolutionary changes, is to really think about useful views, like changing the layer definitions that we have in Inspire, etc. Yeah, I hope that that's pretty much clear. I'm at the end of my time, so I don't want to go much beyond that. And I'd like to open the floor very much for your questions.
So thank you very much, Thorsten. Also a virtual clap, round of applause. So you hear everyone. Let's collect the questions for the end of the session. Mm-hmm. And there's also some communication going on in the chat. It's fantastic to see how questions are answered by other participants. So thanks a lot again. Let's move on to the next speaker. And Jari, Jari Reini from the National Land Survey of Finland is up for the next presentation. And he is looking into exposing Inspire addresses using OAPI feature in GeoJSON. So let's see what you have been doing in Finland so far. Jari, floor is yours.
Thank you, Athena. Can you hear me and see my screen as well?
Yeah, we can hear you properly. We can see you, and we can see you. Yay!
Yes. I put my face online. Sorry about that already.
That's good.
Okay, good afternoon, everyone. So my name is Jari Reini and I'm from National Land Survey of Finland. We just got nice introduction about OGC API and different standards related to that family. So I don't need to talk too much about those things. And then Thorsten had very nice presentation about alternative encodings as well as APIs. So it looks like my task will be to show those a little bit how this works and how those are working in practical work. So the outline for my presentation is something like this. So a few words about OGC API features and its principles, and then what it has to be done with to deal with Inspire. And also as an example, I will explain a little bit about Inspire addresses in GeoJSON. And if time allows, I will show some tools and demos in the end of my presentation. So if we start with OGC API features, Gobe introduced the whole family, and this one is about the features itself and especially about the core. So that's the only one which is currently available as a standard. So it's API building blocks to query content on the web, creation, modify, and other parts will be there maybe later on, as the last bullet is saying about future work, which is ongoing about common query language and transactions. And of course, as Inspire as a community, we are really interested in CRS as we need those for Inspire implementation. What I especially like about this OGC API features is that it's multiple parts. So as a software developer, it's nice to just implement what you need or what your clients are requiring. So it's not a really big set of different conformance classes, but you can decide some, of course, mandatory, but then you decide what additional extensions you will implement. And if we are looking just one slide about the features, how it looks like, it has a landing page. We could say it in old ways like get capabilities in WFS and WMS. Conformance is, as a resource, is describing what it can do. And the data sets are in collections, and then when you are diving into the details of the collections, you will have items which are the actual features. And if we are looking, this is a screenshot from our implementation. So this is in JSON format, and then you can click on different links there, and then you go deeper and deeper, and then you finally get some features as well. This presentation will be shared later on in Inspire website, and there are links in this presentation for all the documents and examples. So this is the OGC API Features landing page. Of course, now we are working in Inspire context, and we would like to use this OGC API Features for Inspire as well. So the current version of download services technical guidelines is mainly using WFS, but in this work we have created a new good practice document how to set up Inspire download services based on OGC API features. So we've been mapping together Inspire implementing rules for download services and OGC API features standard itself. And we had one really big principle that no Inspire specific extension should be added to the API itself. For those who have been working in Inspire context earlier, may remember that we had to implement extended capabilities, for instance, for language extensions, and that caused a little bit problems for some client applications because it's not part of the WFS standard. So in this one, we have tried to map everything using the OGC API features as it is. Okay, so now we have this good practice document, but we will have some future work. So right now, JRC is looking for experts to take part of this new work program Action 2020.1, where we'll create a new version of this good practice document. And of course, we are eagerly waiting for approval of OGC Technical Committee to have this Part 2 CRS extension available. So we would add this also into this good practice document. And then the plan is to prepare and submit this new version of document or good practice document to Inspire MIC and to get more kind of approval to use it in the future as one way of creating Inspire download services. So this is the table of contents of the best practice document. In principle, I would say that chapter 7 is the most important. So there are main principles and different requirement classes. So you can go into that document, which is available on GitHub. You can browse, search it by Google, or you can click on this slide later on. So then you can read the current version of the good practice document. I will not go into the details of this document right now. So now we have Inspire OGC API features, and we've tried to map so that it's compliant as much as possible right now towards Inspire directive. So we don't have yet a coordinate reference system, but that will come maybe later on. So Thorsten had a presentation about alternative modeling and encodings and APIs. I covered a little bit of API already, and now I'm looking into one MICT activity which was related to alternative encodings for Inspire data. And in this example, I will later on use addresses. So this is again a link to or the table of contents to this UML to GeoJSON encoding rules. I will not either go into the details in this one, but you can later on look how the main rules are defined in this document. And we are talking about basic rules. From GML, every feature type is becoming a GeoJSON feature object. Geometry will be a geometry, and all the properties are mapped to GeoJSON properties. So pretty simple rules in that sense to do things. But you can read more about the document described or mentioned in the previous slide. So now if we are looking an example, how it can work in practice. So here we have Inspire UML model and we have addresses, and from here you can map things to JSON model. But I will go this example using GML. So this is one feature of address theme. So one single address where you have first kind of noise over the actual content. So you have street number, and then that's the only information what you currently get when you're asking for a single feature of address. There is this designator and it's saying 58 is the street number. Then we have additional 4 or 5 different stored queries. So you have to go either programmatically or manually to look into what might be the country, municipality or city, or what is the street name. So when you go into these stored queries, first you get a country, okay, we are in Finland, and that's the actually only content I need right now. So everything else is kind of noise around the content. Then another stored query, it's saying the municipality name, and that's inside the red box as well. And last, we have a postal code, which is 62160. So that's the kind of one address point information as an attribute information I would like to show, for instance, in my web application or in my desktop application or mobile application. But currently, if I'm opening by default in, for example, in QGIS, a GML file like this one feature, it will only show the street number 58. So now when we continue from this OGC API features and we implement GeoJSON as an encoding, we might have something, okay, there is a street name still, so 4 different queries. But if we have the same information available as GeoJSON, so here we see, first we have coordinates, then we have properties. And then you can see that this is in Finland in some postal descriptor and in some street number. So this can be quite easily shown in web application or other applications, and many clients can already read GeoJSON automatically without any additional extensions. So talking about tools, I have few examples here. QGIS may be the best well known as a desktop application. It has also server capabilities We will have later on today Python GeoAPI presentation, the last presentation in today's session. There is implementation from GeoServer. We will have a presentation about that as well. But then GDAL or OGR to OGR can read quite well OGC API features. And then very interesting server-side tool is LD proxy from Interactive Instruments, which is running on top of your current WFS service. So if you have WFS2 service available, you can put this LD proxy on top of the current service, and then you have OGC API features available. And I'm also been playing with this PKey feature server, which is PostGIS add-on, or it's a own implementation, but it reads directly PostGIS database, and then it will expose content as GeoJSON and as well as HTML through OGC API features. And there are many other tools available as well. But if we look a little bit into practice, how it works, so this is a screenshot from QGIS. So if you select your layer or database data manager, and then there is one tab called WFS OGC API features, and then you can add your service into there, and then eventually you will have a new layer in your application, and then you can click on the features and get all the attribute information in the same box without doing any additional stored queries. But I can show this also a little bit online. So here I have my QGIS. If I go to Data Source Manager, which is available here, so in first place, I need to create a connection. I already done that, but if we are looking what is inside there, I have NLS AD simple, so addresses in simple encoding. And then what I need is the landing page of the OGC API features. So that's what I showed in my second slide. And then you are selecting which version of the standard you are using, and in this case it's OGC API features. And then when you connect, it will show what datasets are available. In our endpoint, we only have addresses, and then I can add it on the as a layer in QGIS, and now I have layer here, and then I can select and ask different information. So that's how it works in QGIS. In this, I have a API definition, the Open API specification. It explains the license and all the important information, especially for programmers. But if you are looking into actual content, you just go through collections and then what dataset, what collection you have, then items, and then you select in which encoding you would like to have it. If we are looking into our implementation or what I'm using right now, from the landing page, if I'm going to conformance, which is this one, I can see that we support the core, the OGC API core itself, and then Open API specification 3.0, and then GeoJSON as an output format. I also said that it's quite easy to use in different applications. So here I have available buildings from Finland as OGC API features. And if you are looking into source code, it's really supporting it right away. So you just have format as your GeoJSON. You have your URL, and in this case, as our background map is in national coordinate, we mapped that as well.
Yari?
Yes, I heard 3 more minutes, so I still have 2. So the last but not least, also this feature server from PostGIS or using in PostGIS, you can view collections either GeoStation, or if you would like to have it in HTML, that's also possible. So if I'm selecting here view, and you can see that it's HTML, and now I can click on the item and I get all the attribute information available. So that concludes my presentation. I hope I didn't go too many minutes over. Thank you.
Thank you very much, Yari. Also a virtual clap from everyone. Thanks. And as said, we will put questions at the end. Just a very short break, because you hear me speak. I announced new speakers, but I have to say that in the background we have Paul van Genuchten, and he's handling all the technical stuff. So Paul is the supportive guy in the back. I want to give him some visibility as well. Good. Next speaker. So we're half through the more than half through the program. And next speaker is Nuno Oliveira from GeoSolution, and he will give an introduction to the RESTful shameless JSON first download service in GeoServer. And Nuno, it's your time now.
Second.
So we saw the presentation. Yeah.
Yes, I didn't know how to unmute from the full
Yeah.
view.
We
Okay.
hear and see you and see the presentation.
Oh, very good. So good afternoon, everyone. I am Nuno Oliveira, and I will be performing this presentation. So, okay, so I work for GeoSolutions, and well, some of you may know about GeoServer, which will be what this presentation will be about. Okay. So at this stage, you are pretty much all very familiar with OGC API features. And so what I will like to provide during these presentations is actually the point of view of the ones that are, well, that are a bit in the middle. Because here there is more, well, let's say 3 big roles. So the people who actually needs to create models, so it deals with models of the data. So we have real data that may be stored in a bunch of relational databases or other formats, and they need to map it to a specific schema. Then on the other end, we have, well, the people creating applications that will use that data. Well, we can name it web developers typically. And those are the ones actually that will like a lot this new OGC Features API. And then there is, well, the ones in the middle, which needs to make a bit of the bridge. So they need to comply with, well, the needs of the ones that are modulating the data, and they need to serve that data. So what, well, let's put this way. Along the past 2-3 years, we have been dealing with a lot of clients that are publishing in Spire, and not all of them are there at the same stage. So some of them are in an early stage. Some others are actually in a stage where there is full production applications querying the system and serving the data, which means that we get all of the typical problems: performance issues, too much data being transferred, the bandwidth is suffering too much, etc., etc. So this is the ground for my presentation, and I hope this will trigger the discussion for several topics. Okay, so first of all, a quick overview about, I will go very fast because we already had like 3 presentations about this. So let's say well, entry point, the OGC API common. So it defines kind of the entry points that will be common to all the OGC API nested modules. So nothing much to say about this. So we have a conformant class, which will actually say what our server will support, will allow us to do. So which functionalities in practical terms we complied with. The API entry point, which actually will describe for clients, in this case, let's say more technical, software applications that will consume this API and know how they can query your system. And then we have the collections entry point, which is where most of the work will be done. Okay. Well, regarding the encodings, we already discussed it a lot. Well, one of the core encodings is GeoJSON, but other encodings may also be provided. Okay, so OGC APIs, they are linked with modern web, which requires linkers to be available everywhere. So the idea is that if we get something from the web, we will have all the necessary links to go to all the relevant collections, objects that are related with that object. So I guess at this stage we are all familiar with that. When we get a JSON document for an OGC feature API, we always get the link to go to another representation, to go to the next, if a limit was used to navigate through the pagination, etc. So the key word here is linking. Everything is linked actually. So, okay. Another interesting aspect of the OGC Features API is that very little is mandatory, which is a good thing. Usually when we work with the systems, it may seem good at the first approach that you have a lot of functionalities, a lot of buttons to click on, but the truth is that usually we use a very small subset of those functionalities. So having less most of the time is actually better. Why? Because it will make the life easier for those who need to implement those systems, for those who need to query those systems, and until a certain extent for those who need to deal with the data, with the models behind those systems. A quick example, for example, in XML, we have a very powerful way of defining locations. There is a lot of different ways. In JSON, it's an array, and that's it. So it may seem very restrictive, but so far I didn't saw a use case where it actually didn't work. And it makes the life of everyone very simple. Obviously, there is some limitations, but those, well, we'll need to look at them cases by cases. Anyway, the key point here is that very little is mandatory. So we have an API that describes how to query your server, a conformant endpoint which describes what our server can do, and we have the collections endpoint that can be used to query our data on the server. So that's for the OGC API command. And then we have the features API. So OGC features API, very quickly, again, the main entry point will be the collections one. We only support a subset of coordinate reference systems. And then we have no mandated schema. This is very important because this means that we can support a lot of data, which can go from the very simple models to the very complex one with a lot of linked stuff behind it, with a lot of nested objects. And we also have, well, extra possible encodings that each server may implement. Okay. Well, we have the API, nothing special here. And then we have the collections. There is two ways to describe collections. One of them is to say, look, we have a collections endpoint and the name of the collection ID. So this parameterized object will be the one that will actually define the collection. And the other, this is what GeoServer approaches. Why? Because it scales very well. So if you are familiar with GeoServer, if you publish 10,000 layers, your OGC, your API document will only have these three entry points because the collection ID will be parameterized. The other approach requires to create a specific entry for each layer, which will make it very easy. If you have 10,000 layers, you'll have 10,000 entry points. So in GeoServer, we have the first one implemented. Then we have the collections instance, where we can actually use to interact with the data, so to request, well, our features in a specific encoding, to perform a bunch of filtering using the default ones, bounding box, data time, and we'll see later there is a few extensions to support CQL filtering. And we also have the paging. Paging is always a very complicated topic, but let's, well, putting it short, in this case, when we use a limit, basically we'll get links to the next page of data and also to the previous page of data. And that's pretty much what OGC API Features core has to offer. Now there is a few extensions in the making. So to support more or less advanced filtering, to support model projection and filtering using different coordinate reference systems, and also support for transactions, so the ability to write data. GeoServer right now has already implemented a set of the CQL filtering, so it's more or less already working, and working on this too is also planned. Okay. So this was the abstract discussion. What I would like to do now is that I will take one of the real use cases we have, which actually, well, has been an ongoing use case for a few years now. And we'll discuss a few of the problems we found and the solutions, well, we found to handle them. Let's put it that way. So this is an interesting use cases because it has a relatively larger data set. I will do a quick demo, and that demo will be 1 billion of boreholes. So when we deal with data, the size of the data will influenciate a lot of the type of technology we can use. So if we have 100K, 200K of objects to deal with, we don't need to worry a lot about performance. But when we start to go in the range of millions of objects, we need to be careful, because if we send a query and it's not properly dedicated to the underneath data stored and so on, things will be that slow. So we have here more or less a, well, middle-sized use case, so 1 million of objects to deal with. And very interestingly, this is a use case that has been around since WFS 2.0, which means that all the modeling effort has already been done for WFS 2.0. We actually did it for WFS 3.0, which was a previous experiment before OGC API Features. And then now we also make it work for OGC API Features. So this will give us an overview about, okay, this OGC API Features is very nice, very cool, but what do I do with all the modeling effort, with all the mappings I already did on the past? How can I reuse that? And the other interesting aspect about this use case is that we have two situations. So a simplified view, so with very simple attributes, and a very complex one, so with nested objects, related objects. So in a relational database, it means that you have multiple tables that will need to work together. Okay, so here I will actually do a real demo. So this is a bit how it works in GeoServer. So the OGC API Features is an extension you can download and install, and you'll have a bunch of new entry points here in the services capabilities. Today we only look at OGC API Features 1. So, well, we have the expected things, so the API document, which will show us our entry points. And here where we have the our collection page, okay? So here we cannot see anything. Why? Because this is sensitive security data. So actually I need to log in. So it's fully integrated with GeoServer data security mechanisms. There we go. Now we should be able to see it. Actually, I forgot to log in. I'm just using this as an example. Okay, so here we can see our collection. So this is the HTML view. So we see we have two collections, the borehole and the borehole view. So the borehole is the full thing with all the nested attributes and so on. And the borehole view is a simplified view, okay? So going these two straightforward use cases, usually we want the full thing when we need to manage data between systems. So we need to import everything, we need to have access to all the data. And this type of views are useful when we are implementing applications. For example, that we read this data displayed on the map and only show a subset of the information. Why? Because we prune a lot of the data, so it makes the bandwidth usage very low, and it will be faster to query to, a lot faster. Okay, so we have our two collections. We can actually go to the more familiar now JSON view. So here we go. We have our collections defined, and we have the links to the several output formats. In this case, we can, for example, we have several ones supported. So I will collect on the familiar one, the GeoJSON one, and here we go. we get our JSON representation. Okay. If we go to the most complex one, it will take a bit more. I already opened it here. Let me find it. There we go. As you can see, we have a lot more of details. Okay. So we have all our complex properties that are behind it. So as it was discussed several times already today, will GeoJSON be the ideal format to when we have so much data, so many stats? Probably not. But in sometimes it may be. Depends on the technology, depends on the developers' teams, it depends on a lot of things. And this has been one of the main things we have been to deal with lately, which is there is too much options, there is too much use cases to deal with. So we have formats that are very useful, like XML, to fully modulate our world and to, well, create integrations between systems. And we have formats like GeoJSON, like JSON LD, which are also very useful in very specific environments and in very specific use cases. So here we go. And then we have also another problem, which is what do we do with all the data we currently have? Because this effort has been done for several years now, so there is already a lot of investment that has been done in modeling the data. So I have a data store, I have a target schema, I provide the necessary configurations for the middleware software, GeoServer or whatever, to make it be able to understand that data and publish it. And how can I take advantage of all of that? So this is a bit of work in the progressing. So one step back, just to make sure we all have the full picture. So right now, what's going on for most of the modulations that has been done is that we have a data stores layers, and then we have a bunch of mappings configuration in the middle that the middleware server is capable of understanding and serving. So in GeoServer, this works a bit more or less like this. So we don't have restrictions on, for example, a relational database. We can have how many tables we want. Obviously, 1,000 tables will not work very nicely. It will be very slow, but still, we have mappings, and GeoServer is capable of understanding these mappings and do two things. One, to serve those objects according to a target schema, and on the other side, to interpret queries and correctly dedicate those queries to the native relational database and to get only the necessary data, making the queries very fast. Okay, so this is now where we stand, and this is an ongoing effort. So basically, we are coming to the conclusion that we need two things. We need a full powerful mapping between the full gigantic GML target schema, which may be complex as we need, and our complex data store. That's an initial mapping. It's done, we store it somewhere, and that's it. And then we have all of these new output formats. We may have the full GML output format, we may have a derivated JSON output format, we may have a shapefile output format, whatever we need. The idea is that we can reuse all of this effort, okay, to obtain all of these different output formats. The way we are going is that we are using a template mechanism where what you see is what you get. This is an example for JSON LD. So basically you have a file, what you expect to obtain, and then you just reference the properties you know are available, okay? What are those properties available? Are the properties that GeoServer produces in memory after reading from the data store. So either they will be against the full powerful target GML schema or directly related with the original data store. For example, my table, my column. And GeoServer will be able to interpret this, to be able to understand the model behind it, and to do what computers do the best, is doing complex computations. It will interpret all of this, and then it will, well, basically produce us a document that corresponds to exactly what we need, but taking away a lot of configuration complexity from us and give us a lot of freedom in define exactly what we need in a certain scenario. We need to produce the full powerful GML document. Very good. We already actually have it. We need a very specific GeoJSON output for some integration. It's just a small configuration file. Still, we still have
Nuno,
that. Yes.
2 more minutes.
Okay, I need more 20 seconds. So the idea here is that we are actually going one step further, and we want to get rid of that initial mapping. Why? Because if you already use app schema, it may be quite complex to do, even with the support of AIL for very, very big schemas and complex data model. So this will be discussed more later in a session during this week. We are working on a smart app schema store, which will make this initial step even easier. And that's what I had to say.
Excellent. Thanks a lot, Nuno. Virtual clap for you as well. Thanks for participating. I know it's a challenge to talk to the screen and not having the direct interactions to everyone. So great. But before we come now to the last presentation, just a short reminder, or there is a Slido URL you can see in the chat. Paul has just posted it. There you can ask questions as well, which we can address at the very end of the session. So URL is on the chat. Please put your questions there as well. So that brings us to the last presentation of today. We have Tom Kralidis from Meteorological Service of Canada and OSGeo presenting, and that presentation about early OGC API implementations in PyGeoAPI is a co-presentation from Tom, Paul van Genochten from GeoCut, and Angelos Tsotsos from OSGeo, and they are all here, but Tom will present.
Excellent. Thank you, Athena. I'm just going to share up my screen. Oh, whoops. It looks like I'm not able to share up my screen because I do not have the desktop app. I'm wondering if somebody's able to link the I'll send a link to the presentation in the chat.
Paul, are you going to do that, or? Yeah. Angelos chimed in. Excellent, Angelos. Thanks a lot. Okay.
Excellent.
Oh, now Paul took over. It's same. So, okay.
Great.
Paul is sharing the screen. Good,
Excellent.
Tom.
Excellent. Thank you very much. Thanks for the opportunity to present. As Athena said, I'm presenting. I'm with the Meteorological Service of Canada, and I'm a member of OSGeo and on the OSGeo board of directors. I'm also presenting on behalf of the PyGeoAPI project itself, which is a free and open source project, which is it's an international collaboration with numerous people from different countries, many of which are on this call. So before I get rolling, I just wanted to say great job on the previous presentations, and a lot of the work that's been done in this particular project stands on the shoulders of this whole evolution of geospatial APIs. I mean, we've been doing geospatial APIs for a number of years in the community, and we've come a very long way. And this is our current generation of geospatial APIs, focus on OGC API and Open API for that matter, is definitely a critical point in where we're going. So things like the W3C spatial data on the web best practices, things like the significant effort by OGC to try to coordinate all these things and put them together and give us basically a set of solid building blocks to build tools which are efficient, as well as cover use cases accordingly, is definitely appreciated. So as I always say, interoperability doesn't happen by accident, and which is something that Cliff Gottman from OGC said way back, and that definitely applies here. So I just wanted to give a shout out to everybody upstream of the project who's made these kind of things possible. So having said that, let's dive in. So the PyGeoAPI project is basically a geospatial API framework written in, you guessed it, the Python language. It's a server framework. It started in 2018, and it's currently an OS. For those of you who are familiar with OSGeo, it's an OSGeo community project. So I'm happy to announce it's also OGC compliant. So we're compliant to OGC Features Part 1 currently, and I'll talk a little bit about future plans on supporting the other OGC API efforts. As I mentioned before, there's members on the project team that are from different time zones and countries, so lots of core contributors. And again, we leverage a lot of robust Python tooling, which is upstream of us. So we leverage what we can and we develop what we must, kind of thing. Slide down, thank you. So one of the basic principles of the project is it leaves the core data management, if you will, alone. It's downstream of that. So that means it doesn't. The job of PyGeoAPI is not primarily to edit your data or to create or update or delete data per se. I mean, although we will get into that later, but it allows you to publish your data, and PyGeoAPI does its best to not touch the data at all. So basically, you have a shapefile or a geo package or an Elasticsearch backend. All you do is just connect that to the software, and it will do the rest. So it leverages in order to do that, it leverages a lot of Python packages, a lot of GeoPython packages that lets us sort of plug and play instead of plug and pray. Next slide. So diving a little bit deeper as far as a technical overview, the project is designed, the software is designed as a core abstract API. So that means even though it supports the OGC API standards, which are primarily HTTP, you can also use PyGeoAPI on the command line or in your downstream Python project just the same. And then I'll get a little bit into the actual architecture from a high level view, but it allows you to put anything, plug and play all sorts of things attached to the software. So it's a core Python API framework. It works off of a very simple YAML configuration. Maybe this is a good time to go to the next slide. So again, we see the core abstract API in the middle. Again, this is pure Python. And then it's web framework agnostic. So those of you who are familiar with Python web frameworks and so on, the web box up top can mean something like Flask or something like Django or anything else. We do have a default of Flask as far as a web front end. It's a very simple YAML based configuration, which allows you to articulate the service metadata, which allows you to express all the resources that you want to connect to your server implementation, and so on. And as you can see at the bottom, we have a number of different connectors to the core. So basically, these are data provider connectors. So the GDAL OGR tool is a primary connector or plugin that we have in the project. We also support Elasticsearch and CSV, GeoPackage, SQLite, a number of different data providers or plugins. So the way it was designed is that we built it to have this robust plugin implementation and framework, so that you can write your own adapter. So if you have your own data in some format which is local to your environment, and you wanted to connect it to PyGeoAPI, if the onboard data provider plugins don't work for you, then you can basically write your own and plug it right into the software, and it will just work. The same thing goes for writing various processes. So we currently support the OGC API processes draft. So that also works just the same to build your own processes as Python plugins. Next slide down. One more. Thanks. So more on data providers. Again, our primary one is the GDAL/OGR provider. So basically, if you can read your data through GDAL or OGR, for that matter, you can plug it into PyGeoAPI, and it will just work. Next slide. The other neat thing about the software is that it lowers the barrier to data search. So it allows you to connect easily to things like Google Dataset Search, and really articulating the value of linked data and things like schema.org. So when you connect your data into the software and publish it as OGC API features or any other OGC API standard, it includes all that schema.org metadata as part of the software. So you don't have to do anything extra per se to get an out of the box experience. There are some configurations that you can make to provide a more fulsome experience, but you can already do that out of the box, and which again lowers the barrier to your data and allows people to discover, visualize, access, and do anything they want with your data in their own decision support system and so on. Can we go 2 slides to the right? So right arrow, one more. Okay, thank you. So that's a little bit of whoops, thank you. That's a little bit of an overview of the actual software. I'll talk a little bit about who's actually implemented. So as I mentioned, I'm with Meteorological Service of Canada. We have a web services API, geospatial web services API platform called GeoMet, and it provides all of Canadian weather, climate, and water data, both in a real time as well as a archive context. A lot of our data is designed around the weather forecasting or the numerical weather prediction. That's a core piece of what we provide through the APIs, and the other part is we serve out a lot of archive data. Over a century of archive data for water levels and climate and so on. So we jumped on this pretty early in terms of implementation through PyGeoAPI, which and to be clear, we're using PyGeoAPI here at MSC to serve out all this data through OGC API features. So we were able to quickly implement our climate archives and our hydrometric archives, for example, using PyGeoAPI. All of our archives are back-ended by Elasticsearch, and we made them available pretty easily through PyGeoAPI. Once we had that framework going, we are continuing to add more data sets such as real-time hydrometric data sets, water level, and so on, as well as real-time surface weather observations here in Canada. Next slide. And by doing that, we've also enabled plug and play capability for our clients. So one project that was published here in Canada last year is called climatedata.ca. If you go to their station download, their climate archive / station download tool, you will see that you can select stations and do spatial temporal queries, which basically point that back to our PyGeoAPI instance. So the feedback that we've received from that project in developing that client is that it was very easy and very low barrier to implement the client against the OGC API features standard. So very web developer friendly and very very lowered barrier. Again, this is not specific to PyGeoAPI, but specific to the standards in general. But we were able to turn this around really quickly for a high priority project here in Canada using PyGeoAPI. Next slide. The FAO and ISRIC, Global Soil Information System, is also using PyGeoAPI as an external API. they're providing OGC API features just the same, and they've done a lot of work around JSON LD as well. There is also deployments that I don't have written here, although that's a nice reminder to update the slides, that a lot of the groundwater work in the United States is using PyGeoAPI as a means to disseminate the data through OGC API features and leverage things like linked data. So I'm sure there are other deployments, and if folks have any, you're welcome to add them to our wiki on GitHub in our live deployments. Next slide to the right. Awesome. So roadmap. As I always say, the best reward for good work is more work. So what we're trying to do in PyGeoAPI is implement in the same way that OGC has a lot of the building block standards. We're trying to build PyGeoAPI as an extensible tool that can be attached to so many different OGC API standards. So I think Gobe provided a presentation previously of the current list of what's in scope for OGC API. We plan on implementing most of them. We currently support, again, OGC API processes. We are on deck to support the OGC API records standard. We are implementing the OGC API coverages standard. There's work going on to implement OGC API tiles. And for those of you who are familiar with the spatial temporal asset catalog specification or stack, we've implemented that in PyGeoAPI as well. So the very nature of how these standards are developed and the clean break approach that was put forth by OGC and others has made it really easy to turn out software really quickly. And I think this project is a good example of that. So we're planning on supporting all of those things. We're also planning on supporting advanced filters. So the CQL extension that's been discussed earlier on is part of is in scope as well.
Two more minutes, Tom.
Thanks. We're also looking at supporting transactions. So we have 2 Google Summer of Code students who are currently working on CQL and transactions. So we look forward to having their input and contributions into the project, and more OGC APIs and more more conformance and more compliance to the OGC standards to help us provide a wide-ranging platform for anybody that has these requirements. I will probably I will stop there. Sorry I couldn't give a demo, but if you go to demo.pygeoapi.org, I'll type it into the chat. There's a demo there, and I'll send some other links as well. But I hope this provided a valuable overview of the project to people, and how easy it is to get your data through these new OGC specifications using really lightweight and flexible tools. So thank you for your time.
Thanks a lot, Tom. Also, excellent presentation, a virtual clap. Good. I know I'm was a little bit too generous with time, but I would give now the floor to questions. We looked at Slido. There's one question there. But if you have any questions, please post them in the chat or on the Q&A session on Slido. Are there any questions? Okay, everything seems to be clear. There's been a question coming up, or that was posted on Slido, if OGC API features, will OGC API features want support full Inspire data, or will it focus on simplicity targeting a web developer audience? That is something that maybe Gobe can answer. Or are there any other questions? Let me see.
We can give a quick response to that, Thorsten, if you want to.
Please.
Yeah, so actually when we first implemented a version of the OGC API about 1.5 years ago, the first thing we did was just deliver the XML as is, more or less, individual features. So I don't think there's a conceptual problem. I think it's really important to do what we've just also heard here, to make the API, also the payload, really web developer friendly for adoption, because that's one of the key environments that this whole technology stack is for. So we certainly want other encodings as well, but I don't see a conceptual problem with also having like the classical inspired GML being delivered in this way.
Okay. Are there any other questions? Paul, who is in the background, the most important person, is looking. There's no ideas. There's another new question from the previous session. No. OGC API features is optimal for research engines. Search engines will crawl individual features as HTML pages. What about such a page look like? What logo? How should such a page look like? Can anyone wants to answer that one?
So, I mean, what I've found is that, sorry, this is Gobi. What I've found is that search engines will, I mean, provided it's HTML, search engines will index that page and allow it to be discovered. So I suppose, you know, the question of what should that page look like, really it's up to the implementation, or sorry, it's up to the implementer to determine what the HTML output should look like.
Okay. Good. So it's reached the end of the session. A big applause again to all our presenters, Gobe, Thorsten, Yari, Nuno, Tom, and then of course Tom, Paul, and Angelos, and of course the big thanks to everyone who participated, and the JRC, the guys who are handling all the stuff in the background. Thanks a lot. Have a great evening, and don't miss out other sessions. For example, on the 11th of June, there is one on API for Inspire, looking into a OGC API feature and OGC Sensor Things API by Kati Schleit. Have a great day, everyone. Good week, and talk to you soon. Bye-bye. Thanks.